So I'm Jeroen Willemsen. I'm a security architect, full stack developer, front end, back end, modules, etc. And I had a knack for mobile security for a very long period of time already. I started trolling around with Windows Phone, or however you want to call that, or actually Windows Mobile 5 point something, then went through the whole Android thing. And at some point I couldn't evade anymore and I had to start to do stuff with iOS. And well, that's how I got into most of those security things. That's basically me. What we're going to talk about today, we're going to start out with the Mobile Application Security Verification Standard and Mobile Security Testing Guide. Many words, talk about it later. Then we're going to talk about whether you actually should pin, because that's obviously your first question, right? Would you care for pinning? And then we're going to talk about where to pin to, various methods of pinning, and then we're actually going to do some stuff with pinning in iOS. And then we'll show some basic verification and some anti-pinning techniques and have a short recap. If you have any questions, just raise your hand, because apparently I need to come to you so you can be recorded. Or start talking and repeat yourself twice, and then in the end we'll get there. Let's try to make it a little bit interactive, because I hope you'll enjoy that as well. All right, let's get started. So, pinning and many other security controls that you can have for your mobile application are all documented nowadays in a Mobile Application Security Verification Standard. It's a beautiful document written by many volunteers from OWASP, and I'm a co-author of the MSTG, and for the MSVS I'm one of the contributors. And what the MSVS basically describes is, given the security that you need, you should think about at least the following controls. And that will really help, because what I often see with mobile developers is that it's hard to understand, what do we need to do? Should we really go all the way with all these security controls, or can we just focus on creating other types of value? And MASVS can help you to determine what you really need. After you determine what you really need, the MSTG itself, the Security Testing Guide, has guidelines on how to implement, or how to specifically not implement, which is also important, and how to verify. So you as a developer can just download the tools as described within this guide and start using those. And that's a very powerful thing, because that just puts you back into control, so you can actually think about what you really need and what you don't need. Obviously, as you all know, iOS is continuously in development, meaning that SDKs are shifting, new ones are developed and old ones are deprecated. Which also means that some of the controls described in there might be outdated over time. So we from OWASP really need your help. If you're contributing to this guide, it's not hard, it's fairly easy, it's just standard GitHub stuff with markdown files. That could really help us and benefit for the whole world actually. Because we're getting many stars lately and many people are using it, and we see it popping up in different projects, and different companies are starting to use it internally, and that speeds up mobile security quite well, and it can really help in that sense. So please have a look, and most of the pinning that I'm going to talk about is actually described over there. And if you find things that is differently described over there than what I just told you, let me know, so we'll work on it. Okay? Should you pin? It starts with the basics. Who of you is familiar with, HTTPS, TLS, SSL, all that jazz? Who of you isn't? Okay, just a few. So let's quickly describe it. So with TLS, the most important thing is that you basically start a handshake with a bunch of public keys. And then you use the private key to basically encrypt. So the client first sends its symmetric key, which is encrypted by the public key of the server, to reaffirm that you can from there onward use that symmetric key to start payload encryption. But the problem is, of course, how do you know for sure that you actually are talking to the right server, so that you're encrypting your symmetric key with the right public key? For that you're using the PKI infrastructure. It kind of works like this. The endpoint, for instance, www.google.nl, when you go visit it using HTTPS, you'll be offered a leaf certificate, which is signed by another certificate, which then again origins to some root certificate. Sometimes there's multiple intermediates and sometimes there's a direct relationship. But the idea is that overall, the root CA's public key, its certificate basically needs to be in your trust store. If that is the case, then the handshake goes automatically. It's that simple. So the moment that somebody tries to intercept your traffic and starts trying to get the symmetric key which is used for payload encryption, you can't, because it's encrypted with the public key and he doesn't have the private key that's lingering somewhere over here, right? That's the idea. Now reality starts kicking in, because it's often the idea, but not always. Because an attacker might compromise the root CA. Who of you knows about the DigiNotar story? Enough people. For those who didn't know, DigiNotar, very, well, not really well known, but at least often used in the Netherlands, root certificate authority got compromised. Meaning that all of a sudden an attacker started to give out certificates for Google.com, which were used in several parts in the world. And by that, and then basically somebody on the internet detected, hey, that's weird. This is not the public key we're looking for. What's going on over here? And ever since then, they found out, okay, something was wrong over there. The story goes a bit further than this, but it's easy to find it out on the internet. But also other things happen. Symantec, for instance, wasn't necessarily compromised, but they made so many mistakes as a root CA that some parties were starting to say, okay, maybe we should no longer trust Symantec certificates, for instance. So many things can go wrong. Another thing that can go wrong is, for instance, that people get fished into installing profiles where other public keys reside. So all of a sudden, when you install that stuff, you basically end up with trusting certificates you shouldn't trust. So people can now offer those certificates as part of the TLS handshake and then still eavesdrop on your traffic. And some people just make mistakes. They click on things they shouldn't be clicking at. They start installing even though iOS screams very loudly, do you really want this? This might be a security issue. And well, we want speed, right? So click, click, click and done. That's a sad story overall. So that's one thing. The question is, of course, should you still pin? Because, okay, that's a problem, but it's, you know, what I just described, there can be multiple attack vectors where stuff goes wrong. But overall, the question still remains, should you then still pin? And the question actually needs to be transferred into something is your organization mature enough? What often happens when you start having pinning, then the mobile developer guys kind of think like, okay, we got the pinning in there, it works on these certificates, let's continue. And all of a sudden there's, for instance, this rush to replace all certificates because they were SHA-1 based. Run, 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 run. So everybody starts replacing the certificates and the mobile team gets informed the moment the app disconnects and everybody's very angry in the App Store and in the Play Store. Then you're just too late. Because, well, the backender didn't inform you, or that ops guy that always handles certificates for you didn't know you were pinning. So it actually takes proper certificate lifecycle management to pin. You need to align with your teams. The moment you're still debating with your backender why the heck he changed that API and why you weren't informed, then if the API is already the problem, you're probably not mature enough yet to start pinning. That sounds a bit down-throttling, but otherwise you end up with an application not working. And the in-app implementation of your pinning technique is just the next step. Having a solid process in which you manage your certificates is way more important than the actual implementation. Because the implementation doesn't bother if you can't pin anymore because the certificate got replaced. So, and then of course, let's say you weren't that mature in managing your backend and your ops guy has really a problem with keys. How can you be sure that you're protecting the private key correctly? Because even though your pinning might be stable, if you have issues with protecting the private key, why bother pinning? Overall, you should come to the conclusion, or at least most of us do within the security industry, that the moment you have something to protect, like a bank for instance, or like a social media platform, or like a proper game that lives by the hands of microtransactions and tries to make sure you can't cheat, then it makes sense. But if you have a beautiful conference app for your Angular conference, probably you shouldn't pin that. It doesn't make sense because there's not a lot of value in there. I mean, what mostly can happen is that a man in the middle tries to change the schedule. Yeah, I mean, seriously. So think about what you're doing there. really start thinking, does this app even require that? One other thing that's often a misconception is that pinning can help you against an attacker that has control over the device. Pinning doesn't help there. Pinning doesn't delay. Pinning doesn't do anything. And you'll see that in a little movie later on when we do verification. It's very simple to kill that. So it only helps the moment you're afraid of stuff like DigiNotar, or when you're afraid that your customers are residing in a country where where public keys are governed by other governments, for instance. That's where you need to be worried. But in all the other cases, why bother? And of course, there's a media story to it. And some banks are very familiar with that, unfortunately. So where do you pin to? Who of you knows what this is? Yeah, correct. Certificate. So when you do, when you get your CRT file or your PEM file, you can often use OpenSSL, X509, and then some other commands which we'll discuss later on. And you get a beautiful printout: the version, the serial number, the algorithms being used, identifiers, issuer, validity period, some subject, etc. All of that together can be used as one gigantic pin. So you can pin to the entire certificate. But what it really is about is actually about your subject public key information and its fingerprint. So the hash over this is what really matters. After all, we're trying to do something with the public key, remember? No matter what you do over here, of course, having a valid certificate helps in general. Otherwise, your app transport security will block that, which makes sense. But it's more important that you actually make sure that you're talking to a party having the right public key. After all, that's where we're aiming for. Specifically, that part, basically, the public key itself. So you can pin to a bunch of things, as you can see, to the certificate or to the SPKI information or to the public key itself. So what does that mean? So in terms of ease of installation, you can just use the complete cert. You can do a byte-by-byte comparison or create a hash and compare it. And with SPKI or public key pinning, that has become easier recently because many of the libraries that you probably are familiar with, which we'll discuss over a few minutes, basically make use of this already or allow you to do this. Expiry is a very important thing. So when the certificate expires, you need to replace it. The moment you start replacing your certificate, bytes will vary, right? It kind of makes sense because you will have a new serial number or a new expiration date, ergo it can no longer hold. But if you reuse the same public key, all of a sudden you can actually outlive the expiration of the certificate. This is beautiful. The only thing is that then comes to mind is a bunch of challenges. Because, for instance, when you, let's start with the public key this time, how long can you use that same public key? That's the major question. When do you think you can no longer trust your private key? As in, it might have been leaked, or the algorithm you're using might be too insecure. You don't know upfront. So that's something you have to ask yourself and anticipate to. Basically what you can do is just create a new CSR with the same keying material, and you'll end up indeed with having the same keys in there. But then the question is, what will happen next? And by the way, if you're using a self-signed CA, you still need to have a trust store. So basically you're making it very complicated for yourself and you end up with something that's even worse than this. In terms of implementation, that is, right? Because there's more code to it then. But if you pin to the certificate, the CA itself might have multiple certificates that you need to take care of. And well, you have to update more often, right? Because certificates, they expire by nature. Right? Any questions? All right, let's move along. So where do you pin to? A leaf or a root certificate? So over here we have a beautiful root CA or a bunch of root CAs, right? Because there's multiple certificates, cross-signing, yada yada, all that jazz. And here we have a beautiful tree structure with a bunch of intermediates and leaf certificates. So let's say this is yours. Now the question is, where will you pin to? What would happen? And before we're going to discuss that, all of a sudden one of our beautiful intermediates got compromised. And they start giving out leaf certificates for your domain. So what? So what you going to do? Well, if you've pinned on the root CA, this little buddy is still in the domain. Ergo, the moment your client connects, because you're pinning to the same root CA, it won't detect that you're having an issue. Although, if another root CA will be compromised or another intermediate certificate that's not part of your tree, there's no trouble. But right now, you are in trouble. If you, by luck, would have pinned to the correct intermediate certificate, then you are not in trouble. But you could have also, have this one be compromised, so then still your leaf certificate didn't work. And if you pin to your specific leaf certificate, it becomes a bit easier in terms of you're really sure that that's the one you're talking to. And now an interesting caching comes along, because this only works, obviously, if you have a single domain with a single certificate. What if you have a multi-domain strategy? Will you keep multiple pins? Or will you actually, or will you just pin to the intermediate that's shared among those domains? These are quite of intricate questions to answer. They're mostly based on a risk assessment. And the idea is the more you go for pinning to a leaf certificate, the more certain you are to speak to the right server, but the less flexibility will be present anymore. All right? Next thing is about hard coding versus HTTP public key pinning. So hard coding basically means you programmatically define to which key or certificate you're pinning to. You're just saying, this is the key. You implement it in your beautiful Swift code, as in, this is the dir file, it's there. If it's there, that's what we're pinning to, nothing else. That will work beautifully if you indeed have this, for instance, if you're pinning to the leaf certificate, to the same leaf certificate. The fun part starts when that leaf certificate is no longer there. Ergo, you can no longer build your tunnel because trouble. So in the browser world, we did something beautiful. Well, I didn't, but the RFC working group did beautiful stuff there. And that's, of course, was something you can use. And the alternative, of course, is to have multiple certificates over here, multiple public keys. So when you know that you're going to transition, you need to create a new release of an intermediate version of your application that contains both the old certificate and the new certificate. And let's hope everybody updates. And if they don't, good luck. So the alternative is, what I was trying to introduce, is HTTP public key pinning. The beautiful thing of this is basically the server on each request sends a bunch of headers. The maximum age of when you can pin to it, and 2 different pins that are SPKI hashes over where you can pin to, basically. And if something goes wrong, there's an optional header saying report URI. So let's say you can't find any of these hashes anymore, or any of these thumbs when you're doing your handshake, then basically you can report to this URI, something's wrong. This is something that isn't built in many of the libraries, but the beautiful thing is, if you start using this, you become much more flexible. You could even let the max age be related to your actual lifetime you expect the certificate to live, because you already know in advance when you're going to replace it. That's hopefully not on the day it starts to be invalidated, but somewhere before that. So you can already set this up to make sure that the pinning will work. It's all described in this RFC. There's only one problem with it. It's trust on first use, which means that when your customer starts your registration, sending the most private stuff that you need to send to actually start using your application, and he does that in a hostile environment, then you're kind of in trouble. Because, well, if the attacker already controls the infrastructure, he can control this as well. Obviously, chances of this happening is very small, so why really bother? But it's good to still know, because this is an argument that's used often. And you need to set up this backup pin, because the first one is your primary pin where you're going to pin to, and this is basically your backup pin, and the standard requires 2 at least, so you already need to set up your secondary set, which actually is a good idea in terms your first private key got compromised anyway. All right, next, pinning in iOS. Show me the code. First of all, getting the materials to pin. All the slides will be online, so no worries. Basically, you use OpenSSL to show certs of your current connection with your current domain, and then it gets a beautiful printout. And then you can, for your public key, you can either use some program code from one of the libraries which just prints it for you, or you use this beautiful OpenSSL command at the end. where you do need to provide some basic files to make sure you can do the full validity of the chain, because otherwise OpenSSL breaks. And now you basically get the pins of the different parts, which is beautiful in that sense. Now, having those materials, oh yeah, getting the hash, by the way, to make sure you can do the hash over SPKI for HTTP public key pinning, you basically use this OpenSSL command. As you can see, we're still retrieving the same thing, given the root cert, and then we're just using OpenSSL to create a digest, and then encode it properly so you can give it to your application. This is something you can easily copy-paste when you need to use it and move along, have fun. All right? Now if you actually start pinning, the first way is of course using NS-URL connection. What we often see is that authenticate against protection space and did receive authentication challenge are used for pinning strategies, but that's officially deprecated. And there's good reason to do so. So let's move along. The other one is will request sent for challenge, and that's the one you should use if you want to do pinning yourself. Which basically requires the following steps. You first load your certificate in the DIR format, so you convert it or you get it from your backend or whatever rocks your boat first. And then make sure you get, during the handshake, you get the remote certificate that you want to pin to. We have sectors get a certificate at index. Just one thing that's different in iOS than in Android, you guys have a big advantage here. You can't have chain pollution, so the certificates offered to you are cleaned up by the host operating system. So if any attacker starts to inject intermediate stuff that shouldn't hurt, in Android that's different, so don't make them copy your way, okay? That doesn't work, don't do it. Then you evaluate the server trust, as usual. Next step is verify that the loaded certificate or its public key is the same as the selected remote certificate, and you're done. There's many code examples that you can use, but way more easier is use libraries, obviously, because then you can't do this wrong. The first one is using LMOfire. Who of you knows LMOfire? Who of you uses LMO? At least a few, that's cool. So you basically set up a server trust policy with a certificate or keys like this. So you just configure it. I hope I didn't make too many ugly typos. Over here you basically define the certificates bundle, and then you can say validate the chain and validate the host, or instead of that, instead of certificates, use pin public keys. And then you already have the policy. Next you have to instantiate the manager with that policy, and then you're done. It's that easy. So there's no extra stuff over there, which is great. There's only one small weird note. Basically we'll get back to that later on, I believe. Oh no, the weird thing over there is that sometimes it doesn't work. You need to disable ATS. Yeah. So you're exchanging pinning from a third party for ATS. That's something you need to think of twice before doing. Because if you make a mistake over here, or the library implementers implement a patch that might be wrongly configured, then your base configuration, which is very powerful already, which is ATS, is also offline. So you have nothing to start with. That might not be a good idea. The other alternative is using Tristkit. Who of you is using Tristkit? Oh, at least one. So basically you get the pins you want to pin, you enter them in the info.plist file or add them programmatically. And given your visibility of plist files, I think it's a great idea to have them programmatically. And in your URL session completion handler, you have to add the following code. So you set up the pin validator, and then you handle the challenge, and then you're done. And you can, of course, set it programmatically. That's a sample we can put on GitHub later on. Then, of course, how do you verify this? Because it's brilliant that we just did this. I mean, you know, you got your pinner now, we're all good, we're all set, but it might not be what you're looking for. So let's start verifying, right? The one way is using burp, the other one is using ZAP. Who of you is familiar with burp? Who of you is familiar with ZAP? All right. So ZAP and burp are two different attack proxies, which is kind of like Vim versus Emacs. Both are awesome products, but it depends on who you are, what you really like to use. Burp is something often used by pen testers, and ZAP is something used by software engineers. That's because burp is crack hard to automate, and then you still need to do a lot of extra mumbo jumbo before it works correctly, according to how you want it as a developer, whereas ZAP just offers an API out of the box you can start playing. Given my background, it's not hard to guess what I like. But still, burp is a great product. So basically, you use setup burp. You can use burp to generate a certificate for the given domain and install that on your device as an additional certificate. Then you proxy your device through burp. And the next thing is you try to connect with your app at the designated domain. If you can, then you probably pinged wrongly. So something is wrong because right now it should break. And you can repeat the same process, but now with a different host name from step 2. And if you can then still connect, something is really wrong, and otherwise you have some basic verification completed. All right? You can also automate parts of this using MASVS, for instance, which is an automated testing tool where the automation works for Android and for iOS. I hope it will work one day. But you can also do this differently. And for this, we have a little demo video to end the presentation with, mostly kinda. What we're doing over there is we're using the damn vulnerable iOS application. Who of you knows that one, by the way? For those who don't, please start playing with it. It's a bit dated in terms of code, but it can really show you how to work with certain security controls. And especially after the presentation of Pim's talk, I think you'll even love it even more. Basically, what the DVIA is doing is trying to connect to Google, and we're going to intercept that with ZAP. There's a bunch of ways to do that. And in the end, if you actually use pinning, you can so there's a bunch of things you can do. First of all, you can disable ATS when you're already having the host operation compromised. And then you can also use trust kill switches to make sure you can actually disable most of the pinning strategies. And that's what we're going to show right now. So I hope I can just show. It should run already. Yes. So over here you can see my network. This is an old iPad. So basically what you can see over here is I have some network that I'm connected to. I have some HTTP proxy that I'm connected to, which is my local ZAP instance, which is this thing over here. Next, I'm verifying that my kill switch is offline. So you can, when you jailbreak your device, you can easily install this, which allows you to play around with many applications, which is beautiful. Obviously, you're not motivated to do so with your own responsibility, yada, 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 but still it's very pretty. So what we're going to do is we're going to start with the DVIA, and we're going to do some calling around. So over here, we need to basically enter some data. And when we enter the data, we try to submit it. If you just try to submit it over HTTP, no, I think I submitted over HTTPS. Nothing happens because I submitted over HTTPS, sorry. Yeah, I'm not really used to the interface on such a device, sorry about that. As you can see, I have a long history in Android, not so much in iOS. And over here, the certificate pinning got activated, as you can see, so I couldn't intercept anything. Yeah, that's sad. So now I start my kill switch, which disables ATS and the pinning. And all of a sudden, the first stuff already comes in where the DVIA was pinning to, like statistics and stuff like that, which is beautiful. And while I'm continuing, I hope I can remain a bit in time. And now I'm sending again. Oh yeah, I have to add more text. And I'm sending over HTTPS. Hey, there you go, there's the data. And more, as you can see, this is the data we were submitting. So, ta-da! As you can see, the moment you basically got local access, you can start killing it. And the most beautiful thing is that this shows that until we were pinning it effectively, because otherwise we wouldn't be able to submit it. You'll see it again when we try to submit to google.co.uk, because that's where the actual pinning happened. And now there is traffic over there. So until we actually killed the full security stack, we weren't able to communicate to Google.co.uk, showing that by breaking the basic security over there with the pinning, you could finally bypass. Ergo, pinning was properly activated. All right, now there's a bunch of things you can do, of course, with anti-pinning techniques, because as you can see, the moment you get local access, it's goodbye. One thing you can do, and all of these things, by the way, are delay mechanisms when you have local access. That's something you should really know. First thing is you can use payload encryption. You can use asymmetric crypto, which means you repeat the stuff that happens on TLS on an application level layer. The next thing you can do is use stuff like a secure remote password protocol or any other password agreement key exchange protocols. But the cool thing about SRP is that it's zero knowledge based, ergo the actual secrets never are transmitted over the wire. Or any other packet protocol actually suffice. Just make sure you look for one that actually has dedicated support from libraries and doesn't have reported weaknesses, because there's many packet protocols that actually don't work. But they will only, you can furthermore slow down the attacker even more by having anti-reverse engineering controls, so basically obfuscation controls, and have tamper detection in place. So when you, for instance, start pinning, when you have most of these trust killers, some stuff happens on a very low level, which you can actually detect because you can put canaries there when the moment then when those calls and hooks are compromised. So you know that it's the case. When you then stop connecting at all, you basically give away to the attacker, we got you, so why don't you try another way to connect? The other thing you can do is just start reporting to your backend with additional flags, we get trouble. So at least we know somebody broke it. All right, so coming to an end, short recap. Pin only if you have to. Choose your pinning strategy wisely, so just don't run off, pin to anything you think is a good idea. And make sure you pin to something when you're ready, so when you are ready, but when your organization is ready as well, and validate your implementation. For any security control, that's really important. Don't just randomly copy from Stack Overflow. Even though those Stack Overflowers have many good ideas, make sure you verify it. The same holds for the mobile security testing guide. Copying an implementation doesn't make sense if you didn't repeat the verification step as well. In fact, you could combine both. Copy-paste Stack Overflow if you really want to, but still verify. You don't need a pen tester, you don't need us. You need yourself with a healthy mind, proper tooling, and do the work. All right, any questions?
Yeah, question. In your slides about the pinning in Amplifier,
Yeah. Yes.
Do you recommend using the bundle for getting the certificates, or either using them in code base 46 encoded or something similar? As in code versus bundle.
Having them in code makes them easier to control because it's easier to review with your source code checkouts, etc. Having them in bundle might make it easier to package. Security-wise, having something hard-coded in your code is easier because Apple does sign everything in that sense, so you're reassured that the sources are in when there's no, when your signature hasn't been removed because, on a jailbroken device you can run unsigned binaries, blah, blah, blah. But on a normal environment, then it becomes relatively harder to compromise and it's easier to review. So from that perspective, I'd say code. From a packaging this perspective, having them in bundle doesn't necessarily give any trouble if it's just a simple additional control because you're afraid of DigiNotar 2.0, basically. Any other questions?
Did I see correctly that you have to verify the whole chain of trust yourself or up to the CA route? Or?
You don't necessarily have to. And that's also a big argument against pinning that I didn't mention, by the way. If you pin, you don't necessarily have to care about the rest of the infrastructure because it's the public key that all you care about, which basically kills the whole concept of PKI access in general because, PKI infrastructure is about having trust in the root, but you don't have to do that anymore. I would still recommend to do it as a standard in-depth control. So you're not just pinning to something that's valid, but that the full chain is there. But only again if you're reassured that the guys who handle your certificate chain, you know, the admins that have to re-sign stuff, do stuff properly and timely.
But it's not something done by the operating system already.
Well, it's already done by ATS, by App Transport and Security. By default, already all that jazz is being covered. This is just an additional control on top of it. Because ATS doesn't, obviously, handle the DigiDoter 2.0 because it doesn't know.
You mentioned sometimes you need to disable App Transport Security for this pinning or pinning in general. I don't know.
That's
Actually work.
That's pinning in LMOfire. Basically, what the LMOfire README is saying that sometimes you can have CF Network SSL handshake failed errors, and if you get that continuously with your application, you need to disable ATS. That's what the README is saying, and to me that was a bit weird.
But you don't know why.
No, it just random issues fired there, and this solved it. But that puts you in a peculiar situation. So if you're not getting that error, using LMOfire is a great idea to, you know, make sure you don't have to do pinning yourself because their pinning strategy actually works. We verified it. But the moment you do get this handshake error, you might want to move to another library. And don't disable ATS. That's not the answer. Any other questions? All right, thank you very much.